Good evening, everybody. So today is August 17th, right? August 17th, 2021. Today is our first lecture. So you are for my algorithm analysis section 3, right? In section 3. So this course. So everybody has access to D12, right? So at this point, everybody knows how to access D12. Okay, that's good. So again, I would like to welcome everybody in my this course. Previously, I was in FY program. Right now, I'm in software and computer science department. But previously, I was in FY program. So I taught CS1321 and CS1322 for the previous 3 years. Anybody took those courses here with me? You took with me? Huh?
I've definitely had you as a teacher before.
Okay. So okay, so I will be your instructor for this course. Okay, so by the way, as usual, I will be recording my lectures, almost everything. Instead of using like this kind of whiteboard, I want to use a smart board from our next lecture. So everything I will capture, and then I have a YouTube channel. I will post those in my YouTube channel. Okay. So for privacy reason, has anyone any concern about privacy reason that your voice will be recorded and maybe you will be detected by your voice by an intruder or someone? Do you have any concern? Okay, that's good. But if you do have any concern, please email me. Okay, and then do not speak out in this classroom. Okay, so communicate with me with sign language. Okay. So as usual, so let us go through our course content and then course syllabus. So if you go to our course content and then our home page, then start here, you will see our syllabus over here, right? So this is the first thing, and then book. This is the PDF copy of the book. So you see that syllabus, it has version 1.0. So every time what I do, if I find some mistake or any adjustment in my word copy of the syllabus, then what I do, I make the change and I change the syllabus with a different version, with an upper version like version 1, version 2, something like this, or 1.1, 1.2 something. So always follow the latest syllabus over here. Okay, and let me go through the syllabus. So actually I have been teaching another course, same course, another section, that is we meet same day, Tuesday and Thursday from 2 to 3:15 here in this room. Okay, so I will be recording all of my lectures from there and here. So in case I see that I was able to record and capture almost 90% of my recorded video lecture, but sometimes it happens that I started recording and then I could not save it for some reason. Sometimes power went down. So in that case, I will refer my previous section or other sections video. Okay. So I like you to give this favor so that if you do not miss any class. In case you cannot join in person, please watch the recorded video. Okay, before you come to next lecture. Okay. So this is the syllabus, and this is my office will be next. Okay, this is classroom. Okay, my office is going to be shifted to next building, Norton Hall. Okay, maybe from next week I will go there. And This is my office hour, 3:30 to 6 p.m. Tuesday and Thursday. And if you need another time, then send me an email. Okay, and we don't have any TA for this course. There is no teaching assistant. Okay, and this course is actually at this point you are mature. So you are while you are taking this course, right? You took CS1, that means 1321, CS2, that means 1322. You took data structure course, right? And then you took algorithm course, maybe not database course, maybe some other courses, right? And I believe almost everybody is at least halfway. You're done. Maybe some of you will be graduating next year, right? Or within year and a half or two. So I would like to request you to be sincere. Like sincere in this means that you are mature enough. Okay, I don't like to tell you everything. So so our policy is very strict. So do not miss any test, do not miss any quiz, do not miss any assignment. Okay, since you are coming here, you are spending your money, you are spending your time, so why should not you do it at one time? Okay, so the university has zero tolerance on missing test, assignments, and especially integrity. Okay, but I want to give some favors. I will discuss that favor soon, but I am strict in my communication policy. I have some special communication policy. First of all, in line with the KSU communication policy, please never send me an email from your non-KSU email address. You said your Gmail address. You may have your Gmail address, Yahoo, or then your business address or your work address. Please do not send me email from there. So I do not have any personal restriction, but university has a restriction. I have one restriction. You see that in D2L, you can send from D2L, you can send an email from here, right?
Mm-hmm.
Please do not do that. I will not reply to you. The reason is that you can send me an email from here. It will come to me. But when I reply to you, it will not go to you. Then we will get mad, right? That I sent an email to professor and he did not reply me. It happened many times that I replied, it bounced. And if it bounced, then it is double or triple hat-trick for me, triple work. I need to find your email address and then forward that email address or rewrite that email. Okay, so I'm strict. I'm very strict about my email policy. And always please mention your course name and section name, since I have two sections, right? Same course. Okay, even if you say I'm in AA, that means AA for algorithm analysis, is section 3, S3, I will understand. Okay, and at the top line of your email, the first line of your email, or at the subject line, please mention your course and section name. Is this the hard work? So many people, I'm strict. So many students did not like this in previous semester. That professor, why you are strict? I want to be strict really, because I have too many students. And if you ask for any help, but if you do not mention your course and section, then it's difficult for me to, even I know your face and then I know your name, it is difficult sometimes to find it out from class. Okay, and the book, this is the book. Okay, so a soft copy of this book is uploaded here, PDF copy. So the book, you see that more than 1,000 pages. This book is 1,300 pages. So this is the book you will use your entire life, as long as you are in computer science or software engineering. Still, I read this book. So please buy a copy of this book. Okay, and it will be worthy. So in this course we will cover maybe 1/3, a few hundred pages we will cover, maybe 300 or 400 pages. And if you take advanced algorithm course, then same you will be using same book. When you do your master's or PhD, you will be using same book. Okay. So we will not cover whole thing from this book. It's a very elaborate book. Okay. So, but let me go to my exam policy. So there are two kinds of exam. It has given me option what I would do. So open book and closed book exams, right? So for this course, I personally like open book exam. If I were a student like you, I would love open book exam for this. So our open book policy is that let me go through our this. So we have a course requirement 25% assignment at 5 to 6 assignments. Okay, and then 25% quizzes, 5 to 6 quizzes. If I give more than 5 quizzes, then I may drop the minimum lowest quiz grade. Okay, so take all, that will give you benefit. Okay, and then 2 tests, 30%. I may make 15% plus 15%, or 10% 20%, or 20% 10%, whatever. So test 1 and test 2. Okay, and then final exam is 20%. In case you miss any of the test, so the university is strict, it says 0. Okay, but I want to be something flexible, so this is my policy that I made it up and it has been approved. So if you miss one or more tests, that means test 1 and test 2, for any reason, there is no makeup, no reschedule, but this will be compensated by your final exam score with 20% penalty. That means in your final exam, if you achieve 20 out of 20, then you will get 16 for your missing test. Okay, and similarly, if you miss your final exam, then I will make average of this test 1 and test 2 previous test, and then you will get 25% penalty. Okay, so, but there is no makeup or no reschedule. Okay, I will give several announcement about the exam and test dates. Okay, so there is no extension or makeup for quizzes, but there is an extension for assignment. So in the assignment, I will put due date and extended due date. Extended due date, during the extended 2 or 3 days, you will get 10% penalized for each day or part of a day, even 1 hour or a few minutes of a day, 10% penalized. Okay, so for instance, if you have an assignment, most of the assignment will be due in the weekend. So if you have an assignment on Sunday, if you cannot do it on Sunday, if you do on Tuesday, then it will be graded out of 80 for 2 days late. Okay, but at least better than nothing, right? Okay, so this is my teaching philosophy and instructional method. I like you to be collaborative and study this course material with your friends, okay, anyone, but please maintain your academic integrity. Do not copy and paste from somewhere. Okay, so university is very strict. I will be also strict. The university asked me to be strict. Okay, so if you get caught, then it will get severe punishment than not submitting something. Okay, and then please go through this syllabus. I like you to go through this syllabus, and then at least one time it will need you like 20%, 20 minutes or 30 minutes. You just skim out. Okay, for the test, okay, so you will need a webcam. Before the test, I will announce, so be ready to that. You need your own computer and a webcam. Okay, even if we take the test from here, you may need a webcam. Okay, so since your course is online, but this is the requirement, you need to have a webcam. Okay, and another thing is that, as I discussed, the exam policy. Test policy is I can do closed book or open book. So this is my open book policy. So with open book test, you will be allowed to use any printed materials, your own materials. Okay, it's not that in the test you can use book, if you cannot use, but you cannot use any electronic resources. That means the PDF copy of the book you cannot open in the test time. If you have a hard copy of the book, print copy, you can use it. Okay, if you have 100 pages print out or your handwritten cheat sheet, I'm okay, I'm fine. My goal in this course, so are you okay with this, my policy? If you don't like this, then I can go close book test. Okay, my goal in this course, let us go to our objectives of this course. So our objective is to demonstrate the basic understanding and design concept of algorithm, designing algorithm and analyzing algorithm, so that you can analyze an algorithm and figure out whether it is a good algorithm or better algorithm or best algorithm. Everybody knows what is an algorithm, right? An algorithm is a step-by-step process of solving a problem, right? An algorithm has two things: some data and some instructions, right? Okay, we will go through this. So an algorithm is a solution to solve a problem. In real life, we always use algorithm, right? We may not realize that we are using an algorithm. The algorithm, before we come in this morning, we come to office or school, we dressed up, we clean up, we took our breakfast, and this is the process, right? So every day we follow algorithm by knowing or without knowing. So our goal is to learn how to design good algorithm. So how to design good algorithm? We need to analyze some algorithm. What do we analyze? First of all, we'll learn how to analyze existing algorithms. Okay, then if we understand how to analyze an algorithm, how to examine an algorithm, how to comment whether it is a good or bad, then we can develop our algorithm and we can analyze our own algorithm. We may be able to say whether it is a good or not. At least 80% cases will be true, will be successful. Okay, so in this course you see that the book is very large, so I don't like you to memorize anything, but I like you to understand the concept. Okay, this is why I like you to read the book, read the slides. Okay, print out, and whatever you do mark it and use pen or pencil. In the test you can open the book and whatever you like and just solve the problem. In the test, if I would do closed book, then the question would be easier, and then if I do like this open book, then the question will be something you need to do critical thinking, right? A little bit challenging, right? You will not get it in a book, but in the book you will get the process. You will follow the process. Okay, so these are learning outcomes. So in this, at the end of this course, actually you will be able to analyze, you will be able to learn how to analyze algorithm. So you took data structure course, right? So this course, actually, if we go through all the way, and so this is the topic and tentative schedule. It is not final. Okay, it is not finalized, but I believe it is 80% finalized. So in case you see that I have some open space for the due dates. So in case, for instance, I could not make an assignment here, we could not do it. In case, we will shift it to the next week if needed. Okay, so in that way, that in the previous semester what I did, I made the schedule like version 1, and whenever I made some changes or any shifting, I made version 2, version 3, something like this. And then everything I uploaded in D12, new version. So some student commented that the professor changed his syllabus 6 times. I did not change the syllabus. I updated the schedule based on your need. It was not my need. Okay. So they could take it positively, but someone took it negatively. I know the reason. Some students sometimes they ask for some favor, but my hands are bound, right? Hands are tight. I cannot give any favor if that does not fall in a rule. So you see that this course, it is something that you are familiar with, like sorting algorithms and these data structures, elementary data structure, and something you will learn something new and in depth. Okay, so we have 2 exam dates. So unless otherwise stated, so these dates are fixed. So for your course, the test will be here in this room, okay? But you will be using your own computer. I'm not sure we can have paper-based test, or we'll discuss that later, okay? Whatever you need. Okay. So I have a YouTube channel. So in previous years, previous semester, since I have been teaching here for more than 3 years, I record all of my lectures. I have more than 500 lectures over here. So every semester and all of my lectures I record and I put it here in my YouTube channel. As I said, if you feel uncomfortable to be recorded or to be your voice recorded, so please be careful, okay? Do not speak out loudly. Talk to me with your sign language. Okay. So that's all about the syllabus. Has anyone any question? Or anyone has any suggestion? Or any opinion?
Will test dates move at all? Any possibility for that?
Test?
The dates of the test, is there a possibility of them moving?
I don't see any reason, unless there is a reason. Why should we do that? If there is a reason, valid reason, right? I can be sick. There's maybe have an issue. Then we will move. We have some options that you see that we will move here. But I have organized the test, for instance, here on this date. So basic to sorting, we will complete sorting previous week, and then we will be testing this year. Okay, and then here, before these 4 weeks, I will cover data structure, and then we will be testing data structure. I spent some time to develop this, so unless there is a reason, I will not change it. Anyone has? But did you think that you have? Is there any reason for you to?
I need to take off of work the test date just to make sure I'm good.
Yeah, I will announce it. So the test date are fixed. Okay, so your our lecture is evening time, so maybe you will not be working, right? So it is after hour. Okay, that's good. Anyone has any other question or opinion? Okay. So let us go to our D12. So if you go to D12, you see that PDF lecture slides, and I have PowerPoint slides. I will do that. So this course, especially this course, there are a lot of students. I know there are 8, maybe 9 sections for. No. Not this one. Data structure course at 8, 9 sections. There are multiple sections for this course, but we teach not in a group, but we teach also collaboratively. If someone develop a lecture slide, we share with each other. We professors share with each other. Okay, so sometimes you will see the PDF files over here. You see that, but you may see that other professor's name over here and information. I did not change it to give them credit, but just for that this is from other professor, okay? And sometimes I give out my slides to them. We share. So I think it should not be an issue. Okay, and let us go through. Do you have any question? Okay. So we have a few more minutes. Let us learn at least something tonight before we go. Let us take something to home. Okay. So let us recall that what is an algorithm. So an algorithm is a step-by-step process to solve a problem, right? You know that. An algorithm has two basic elements, some data and some instructions. Data we take input as raw data, and we process the data using the instructions, and we give output, some kind of processed or finalized data, right? Okay. So then whenever we develop an algorithm, we always want to develop an efficient, a good algorithm. So how do we say this is a good or bad algorithm or a better algorithm? By measuring its efficiency. And how do we measure efficiency of an algorithm? By analyzing the algorithm. So in real life, right, whenever we compare one thing with another thing, how do we compare? Is this heavy or weight? Is this costly or less price, right? Is this bigger or smaller? Something like this are our comparison tool, right? So similarly, we will find that we will analyze our algorithm in terms of mainly most of the cases how much time it takes to solve the problem. Okay, so sometimes I tell a story that, okay, how many routes are there if you want to go to downtown from here? How many different routes or routes or whatever you say, different way you can find. Yes. If you want to go downtown from here to Atlanta downtown here, okay, how many ways you can go, or how many routes? Huh?
I guess I think like 20.
You guess 20?
Yeah.
Okay, anyone has a different opinion? More or less than? Huh?
It's an extremely large number.
It is unlimited numbers, it can be, right? It depends on our need, right? And then our resources and then our ability. Okay? The straightforward could be through 75, right? I-75, right? If but that is blocked, we may use 285, something like other way, right? But you see that from here to downtown there are multiple ways to go, but which one is efficient? Can you tell that which way will be efficient?
At a good time, 75.
Hmm?
On a good time, 75.
Yeah, we cannot tell exactly which way will be efficient, right? For instance, if you need to go quickly, then you may use I-75, right? If you need shortest distance, then I-75. But if this distance is not a factor, for instance, you need to pick up your some of your relative, your mom or your dad from Florida, and you need to take him or her to downtown, okay? You want to go together. So then you will go Florida first, right? And then go Florida, then Savannah, then come here. That is more efficient for you, okay? Instead of going downtown first. So for instance, another way, I can go Alabama and then come back. Right? I can go Montgomery and then come back. So for instance, if you are given an option that you can have unlimited money as much as you need, okay, enjoy your trip, okay, you just need to go to downtown. Money is not a matter and time is not a matter for you, right? So someone may think, okay, I will go to California or Paris or London, then go over there and then I will roam all over the world and then come back to Atlanta. That could be efficient for him or her, right? So it depends on the situation. So whenever we develop an algorithm, the algorithm will say whether it is efficient or not. Okay, so but we will analyze the algorithm, and then we will then, based on our analysis, we will come up with a solution that whether this algorithm is good or bad. Okay, people are doing a lot of research. Still, computer scientists and software engineers, they are doing a lot of research in this with algorithms. Like for instance, developing a very simple sorting algorithm, right? We know from our early childhood, we know how to sort some numbers from ascending order, smaller to larger, or descending order, right? We know it from our childhood, but still a lot of research is going on how to develop a good and efficient and better sorting algorithms. Still research going on. Newer algorithms are being developed. So when we will develop our algorithm, our goal will be to develop an efficient algorithm. But we may not be successful. Not okay? But we will try. Something is better than nothing, right? If we can come up with something, then that's good. Okay. So main two things in order to make a program or an application efficient or faster, we need to do two things: data structure, good data structures, and good algorithm. So everybody has taken data structure course, right? So everybody passed this course, you're good in data structure, you know how to arrange your data. Okay, and you also know algorithm. You have been developing algorithm for a while. But our goal will be to make a good combination of data structure and algorithm. Okay, so it is said that if your data structure is good, then you are 50% done. Your algorithm is 50% efficient. If you do this part, then the remaining part will not be tough. Okay. So here you see some data. So this is an array type data. So it says apparently it looks 1, 2, 3, 4 data elements, but you see there are dot sign. So that means there are many more data elements. So we say in general, we say there are n elements. So this is the right side is pseudocode, pseudocode format. In array, there is a basic difference between pseudocode and actual code is that in programming languages, we start with index 0 for array, right? For almost all programming languages, start with index 0. But in pseudocode, you start with index 1. So if you start with index 1, then 1 to n for n elements. And then if you start from 0, then 0 to n minus 1, right? The same thing. Okay, so this is part of an algorithm. By looking like this kind of pseudocode or actual program code, we will learn how to analyze this algorithm. Okay, let us see an example. Like, let's see an example here. Okay, so this is part of an algorithm, for instance, here. Okay, so then let us learn how do we analyze this algorithm. Okay, please give attention for the next 5 minutes. Okay, so here you see that we have for loop, one for loop, another for loop. Okay, and then we have only single for loop over here, and we have some single instructions, simple statements. This is single instructions, one after another. Okay, we don't know how much time it takes for a computer or a processor to execute this statement. Let us consider 1 millisecond. Each statement takes 1 millisecond. Okay, so then here, for instance, let us think that we have 25 instructions over here, 25 statement. So each take 1 millisecond, so it will take 25 milliseconds, right? Okay, so this 25 millisecond is here. This is 25 millisecond. We want to find the time, how much time it takes. Okay, let us come with bottom, then we understand easily. Now here, this is middle part. In the middle part, how many instructions are there? There are 5 statements, right? So it takes 1 millisecond, then it takes one iteration takes 5 milliseconds, right? And then if it has 0 to n, I equal to 0 to I less than n, then how many times? N times, right? So if it takes 5 and then 5 times n times, right? So n iterations, we don't know n yet. N can be 2, n can be 3, 4, 5, 10, 1,000, million, billion. Okay, n is an unknown number over here. So our goal will be to write an algorithm that will be applicable for any number of data. Okay, so it will take 5n because there are 5 instructions and then n number of iterations, so 5n. Okay, and then it has only 25 instructions, so this is 25. So has anyone any question about this two part? Okay, now this part is a little bit complicated. Let us understand this. If you understand this, then you will understand many more like this. So here we see that there are 2 for loops. See, there are 3 for loops here, right? 1 for loop, 2 for and the second, and then third. But this for loop is independent to these 2 for loops, right? These are separate. But this inner for loop is dependent with outer for loop, right? So then see how many times this simple statement executes. Let us think that we consider that it takes 1 millisecond, right? Each time execution it takes 1 millisecond. But so how many times this will be executed?
N to the second.
Y into the second? Yes. Y n squared?
Because there are 2 for loops, so n times n is n squared.
Yes, but for loop, because you see the for loop are internal, there is one internal for loop. Is called inner for loop, right? So you see that this for loop is independent, so it is fine, but this is inner for loop. So this for loop will be executed how many times? N times, right? And this will be executed n times. So this will be executed n times n squared, right? So here, so this is why n squared. If I would have 3 inner for loops, the complex for loop, then I would get n cubed over here. Yes.
What if you had a simple statement inside the first of the 2 for loops?
What I would have another simple statement here,
Yeah.
right after. Okay, that's good question. We will come that soon. Okay, let us think. So here, so that our total t means time. Total time to execute this algorithm with n. We don't know n yet. We said, right? We assume that we don't know n yet. N could be a smaller number, it could be a medium or larger number. So this is our formula. This is a function, right? A map function to find the time complexity. So most of the time algorithms are measured in terms of how much time it takes. So in this term, so the n squared plus 5n plus 25. So which term is dominant? Can you tell me? Which is the dominant term?
N squared.
Okay, n squared. That's good. Anyone has any other option? Okay. Actually, I don't know yet.
Well, yeah, if it's a small case, then obviously.
I don't know yet. Actually, I cannot. I'm not sure because I don't know n. Right?
Yeah.
If n equal to 2, let us think n equal to 2. Then which part is, which number is dominant? Huh? 25 is dominant, right? If n equal to 2, then 25 is dominant, right? If n equal to 3,
Still 25.
still 25, right? If n equal to 4,
Still 25.
still 25. So in case of number 2, 3, 4, at least a few numbers. We got few numbers, right? In that case, 25 is the dominant number. It takes more time. This part will take more times. If our data size is smaller, then this part will take more time, right? Then it will take total, we can say that it will take 25 milliseconds time, okay? But we will mainly consider for large n, larger n, okay? So for instance, we can say we not actually infinity, but we can say this is the term infinity, right? So if I add up another infinity, one infinity plus another infinity equal to how many infinity? Huh? Huh? Infinity plus infinity. What is the result? You didn't hear that question earlier? Infinity plus infinity. A very large number plus another very large number. What is your result?
A very large number.
Yes, this is one infinity. That's good. Only one another infinity, okay? So even you subtract an infinity from another infinity, you cannot say 0 because you don't know their actual figure, right? So here, in case of n is a large number, then you see that this part will be dominant, right? N squared will be dominant. Okay. So it depends on size of n. If it is n is very large, then this part will be dominant. And in that case, we say that is big O, capital O, n squared. This is the symbol we said, n squared. That means in the worst case. In the bad case, that means if n is a very large number, it will take n squared time. So then if n equal to 1 million, then 1 million squared millisecond it will take, right? A very large number. It is not a few seconds. Okay, so this is the way that we analyze our algorithm. So whenever you will be able to, you will write your algorithm. This is the way you analyze your algorithm. Start from the simple part, then go to the complex part first. But whenever you understand, because I understand, then I could start from here. Okay, but it seems to me easier to go from down to up. Okay, I will answer your question, but anyone has any other question before this? Yes.
What kind of languages would you be looking at for programming?
Programming, I'm open. You can use C++ or Java.
Okay.
Okay. You are asking about assignments, right? Only you are asking about assignments, right?
Yeah.
Only a few assignments will be programming. Many assignments will be demonstrative. Okay? Yes.
When are we going to start doing those programming assignments? Halfway through?
There is nothing due this week, so this is add drop week, right? So some student will be added and some will be dropped. So from nothing due until next weekend. Okay. And please keep your eyes on D12. Yes.
On each will in the assignments tab is showing all the summer assignments, if that's.
Yes, that was summer assignment. I did not upload. I did make this up. I will do this by the weekend or next week. Okay. Now, someone asked me a question. If I have, let me come here. If I have multiple over here, two statement over here, or five statement over here, what would happen?
It'd just be 5n squared.
So for instance, if I have two statement over here, so then it would have 2n squared, right?
Yes.
That will be 4 2n whole square. Like I would have like this, 2n whole square, right? So if I have five statements here, another five statement, single statement over here, then I would have 5n squared. And then in case of large number, we can say always say 25 or whatever you say n squared, right? So the constant number we just keep this, because in case of large number this is nominal, right? So now you understand, if I would have multiple statement over here, how would I analyze this? Like this, 5 statement 5, okay, 1 statement that 1. Now here's a question that if I would have another statement here within this for loop and this for loop, between these two for loops, right? Then how let us see that how many times this would be executed. So if I have one statement over here, that would be executed n times, right? So then, and then this will be executed n squared times. So then I will write another, the tn will be here n. Okay, the first n for this statement, you say this here, right? Keep your eyes over here, please. This will be here, so it will be executed n times, and this one will be executed n squared. So n plus n squared plus how many times this one will be executed? 5n.
5n, yeah.
Plus 5n plus how many times? How much time it will take? 25 plus 25. So here, so what I get over here? So n squared plus 6n plus 25. So almost same thing, right? So which one is dominant over here? For the large n.
N squared.
Still n squared, right?
Yeah.
But our analysis is different. Okay. Do you understand?
Yes.
So the same statement, a single statement over here, if it comes here or after here, after this for loop, same thing, right? In that case, I would write like differently, n squared plus n plus 5n, right? Has anyone any question? Do you have a question? So this is the way we analyze. We will start analyzing small algorithms. We will learn then complicated algorithms, okay? But we need to start with simple, something simple. And ultimately, our goal is that you will be able to analyze your own algorithm. For the interview or test question that you ask, you have to write an algorithm that takes n times. Okay, this is called linear times. This is n is linear, and this is quadratic or exponential. So when writing an algorithm, efficiency is our main goal. Okay, now let us see. I use this word. Okay, so instead of this, if I have an algorithm, this is my handwritten, I wrote it in previous lecture. Okay, so I have an algorithm like this. So this is a for loop for I equal to 1 to, if say you start with 1, then less or equal 1, right? Then equals and needed, then n times, then I plus plus, and do something, maybe task 1. Okay, that's statement 1, statement. And then there is another for loop for j equal to 0 to j less than n. And how many times over here? Still n times, right? Okay, and then over here do something, and then you have another statement, another for loop. So you see that these are not inner outer, these are independent.
Yes.
Right, one after another. So this one will be executed first, then this one will be executed, this one will be executed. So then it comes 1 to k equal to n minus less n, or I can say that, let me say like this, n minus 5 for instance, k plus plus. Okay, do something. So let us analyze this kind of algorithm. What will be your time complexity? How much time it takes, right? So for this part, what will be time complexity? We say big O n, for instance, or n. We say we will understand big O n, what is called big O n next lecture. Okay, this n, and how much time it takes? Still big O n, right? And how much it takes time? Big O n minus 5. How many times it takes? I said n minus 5, right? 1 to n minus 5, right? So if I add up this, so big O n plus big O n plus big O n minus 1, n minus 5, right? So our total time will be big O n plus big O n plus big O n minus 5. So then what will be total time? Which part is dominant?
Bn.
N, right? Big O n. So for a large number, this is 5 is not a factor. Even if we say plus 5, we say plus 5 here or plus 5 over here, still big O n, right? So at this point, as I said, that you took CS1, Computer Science Foundation, you know object-oriented programming, right? Everybody, I believe everybody knows object-oriented programming. You know data structure. You took database course, right? Maybe some of you took other courses, maybe digital system, maybe computer networking, or other courses. So at this point, you are mature enough. So this course would not be not difficult if you give attention. Okay? You don't need to study whole. I like you to study like regularly, not that you will give focus only on the assignment day, okay, on the test day. You will not do that. So do something, do every day little bit, okay. At least whenever you come to lecture, at least try to get something in your mind. Try to learn something, right? So what is our take home for tonight? What did you understand?
Work algorithms from the simplest parts to the most complex parts.
Yes. So there can be some quiz question from tonight's discussion, okay? For instance, if I give an expression like this, and I can say for a specific value of n, which term is dominant, right? So if I say for n equal to 3, which term is dominant? Is n squared, 5n, or 25? So for n equal to 3, which part is dominant? 25. That is the question. Okay. Yes.
But we're always going to assume the worst case, correct?
Yes. So while unless you are given a specific value, you are given a value for n, we will consider the large n.
Okay.
But as I say, for n equal to 3, I said n equal to 3, right? So you got specific n. In that case, not n squared is dominant. 25 is dominant. If I say for any n, for a large n, then n squared is dominant. Okay, if I would have an expression like this, like so Tn equal to n squared divided by 5 plus 5n plus 20, for instance, something like this. So you see the n squared divided by 5. Which one is still dominant for large n?
Yes, the n squared is still dominant.
Still n squared dominant, right? For large n. Even if you say 500 over here, still this part is dominant, right? If you say 500, or if you say like something like this, plus 5 to the power maybe 5, right? Still, which part is still this part is dominant for large n? Okay, because this is constant. This is constant part, right? So just get rid of the constant part, then we'll see n squared plus n, then which are the parts. Okay, so there is something that I will discuss in our next lecture, but I want to give you a homework, something. Okay, I will give you a quiz based on the syllabus and my policy statements that I discussed this lecture at the beginning, and I like you please download the book. Okay, and as I said, if you want to take facility of open book test, then you should buy this book. You can buy maybe used book or new book. It's available online. You will need this book for a long time. Okay, then open the book. So go to the first page, first few pages. At least try to remember the author names. Okay. People usually know the first author name, last name. Okay. So when I was a student like this, we knew that Cameron book. It's a Cameron Corman book. Corman and Stein. Okay. And then what I like you to do, you don't need to memorize anything. Just spend few minutes to go to the content page and see what are the chapters over here. Okay, read the chapter title and see what are the subtitles over here. You will see that something you are familiar with. Some of this item will be familiar with. Okay, so just go through this. Just go through this. Here to how many? You see that? 35. 34. So we will cover also this 34. This topic at the last week. Okay. But okay, be familiar with something so that we will see. Don't get panic. Okay. We will not cover everything. We don't need everything, but sometime we may need it. And whatever we can do, we will try our best. Then, if you have some time and some interest, okay, then go through these few pages. You see that first 30 pages, chapter 1 and 2. Okay. If you get interest, I believe if you see the syllabus, if you see the content, you should have interest that for some people who wrote the entire thing, they spend hours after hours, years after years, right? For writing the book. And why should not you spend 30 minutes to read a few pages? Then I'll be happy if you do that. Okay? So everybody agree? Okay, please do it, okay? Okay, has anyone any question? So again, one thing, please, whenever you send an email, please use KSU email address. Do not send email from D2L, and do not forget to mention your course under. You don't need to say thank you. Okay, I will be happy. I will not be unhappy if you do not say thank you. You don't thank me, okay? But I will be unhappy if you do not write your section name or course name. Okay. Okay. Thank you, everybody. You have a good night. See you day after tomorrow.